Welcome to another tutorial on the thermal system design class. So today, after we already covered all the setup, we're gonna start going into the solutions. So one of the first things that we can see is that we click here on solutions and on methods. We have the solution methods, the pressure velocity coupling. Right now it says couple. So this is basically the algorithm that is gonna use. So most of the time for CFD simulations that we're gonna use simple. You can look it up actually. If you look for the simple algorithm, it's gonna tell you the how it's performing the calculations. But we're not gonna worry about that too much. We only want to know how to utilize this option. So most of the time we're gonna go for simple. We can see here on the spatial discretion that we have the gradient for whichever you want to use. Let's leave it just on the standard one, but we have the green Gauss cell base, green Gauss node base, least square cell base. Let's leave it as that one. You can see the pressure. You see we have it selected on second order. That's really precise for what we want. Let's leave it at that. Momentum, we also have second order upwind. It's going to give us better solutions than the first order. And that's basically some of the solution methods. If we go here to control, so controls is giving us, because the method that we selected, let's say for example that we change it to couple, it was at the beginning. So we can see different solutions. So it's telling us now the pseudo transient explicit relaxation factors. And if we go to simple, it's giving us just under relaxation factors. So it's a little bit easier. So it's, if you know the numbers, you can change them. So you know the pressure, then the momentum. Most of the time, density and body force, you're not gonna change it. But if you do not know the numbers, just leave pressure and momentum as default, and it should give you a good answer. You can see here on report definitions. Now let's click on monitors. So on monitors, it's gonna give us all these options. As you can see, the task page is not giving us the actual options. And one of the most important things when you're running a simulation is here on residuals. So residuals is basically, this is gonna tell you whether your solution is gonna converge or if it's not gonna converge. So we can see here the equations for the solutions. We see the continuity, the criteria that it has to meet, the x velocity, the y velocity, just because this is a simple 2D problem. The options, if you want to print it in the console, if you want to plot it. And this is going to be very important. If you increase the number of your criteria, you're going to have a more precise solution. But the problem is that you're going to increase your computational time by a significant amount. If we just add a 1, 0 to each of them, it's just add a 1 just to not make it crazy on the time. The report files that is going to give us. Here is going to see the report plots. We can see that there's nothing on cell registers, so we go to initialization. So here is going to give us an initialization method. I recommend going for just hybrid. It's going to give us a more precise solution. So this, if we click on here, is going to give us some initial solutions before we actually run our simulation in order for it to be more precise whenever it runs. So here we have calculation activities. We're not gonna mess with those too much right now. And lastly, we have run calculations. So here is gonna give us our parameters, the number of iterations that we want. Let's say, for example, that we want 400 iterations. The reporting interval, We can check case. If whenever we check case, it's gonna give us any recommendations to do before we actually run our simulation. As you can see right now here on the console on the text, that there's no recommendations at this time. So let's leave it at 400 iterations and let's calculate it. The solution must be initialized before the. Do you want to proceed after? Yes. So you can see the initialization that we were talking about right now. So right now it's performing iterations and this black line is your continuity. What you want is for this black line to decrease. So if it starts increasing, let's go back to our iterations. So if it starts increasing, we're not gonna. That means that we're not converging. So we can see our solutions right now, and we can see all the iterations that it ran. So until now we haven't reached convergence. Let's add. So if you add another 300 iterations, it's gonna start from where you leave it up. Yeah, it's gonna give us the option to continue or to change it. We'll just continue with it. You let the simulations run. So right now it's not reaching convergence. Maybe we have to change our controls a little bit more. Go to monitors. We go again to residuals. Let's make these numbers a little bit smaller. Okay. Run calculations again. Let's run another 300 iterations. So your continuity is not looking like it's not gonna converge. Sometimes your solutions don't converge. So the more that you improve your setup, the more it's gonna start converging properly. So in the next tutorials, we're gonna see how to post process our results and how to get the graphics and the contours that we want.